Hello everyone, I'm Snega Priya, Assistant Professor, Department of Information Technology. So now we have to learn about page replacement algorithm in OS, that is operating system. So first we have to know about page replacement algorithm and why we need page replacement algorithm. So in our earlier the discussions of the page fault rate, we assumed that each page fault at most once when it is first referenced. So this presentations is not strictly accurate, and however if a process of 10 pages actually uses only half of them, then demand paging saves the IO necessary to load the 5 pages that are never used. So we could also increase our degree of multi-programming by running twice as many processes. So thus we have hot 40 frames. We could run 8 processes, and then the 4 that could run in each require 10 frames. So further consider the system memory is not used only for holding program pages. So buffers for IO also consumes a considerable amount of memory. This use can increase the strain of memory placement algorithms. So deciding how much memory to allocate to IO and how much to program pages is a significant challenge. So some systems allocate a fixed percentage of memory for IO buffers, whereas other allows both user process and IO subsystems to compete for all system memory. Okay, so why we need page replacement means, so prevent over allocation of memory by modifying page fault services routine to include page replacement. So use modify but to reduce overhead of page transfers only modified pages are returned to disk. So page replacement completes separation between logical memory and physical memory, and large virtual memory can provide it on smaller physical memory. So why we need page replacement algorithm? Okay, so over allocation of memory manifests itself while user process is executing a page fault occurs. So page operating systems determine where the desired page is residing on the disk, but then finds that there are no free frames on free frame list. All memories in use. So this is figure will explain that. Okay, so the operating system has several options. At that point, it could terminate the user process. However, the demand paging is the operating system's attempt to improve the computer system's utilization and throughput. So users should not be aware that their process or running on a paged system or paging should be logically transparent to the users. So this option is not the best choice. So the operating system could instead swap out a process, freeing all the frames and reducing the level of multi-programming. So this option is good one in certain circumstances. Okay, so we have to discuss the common solution of page replacement. So basic page replacements. So normally the page replacement take the following approach. If no frames is free, we find one that is not currently being used and free it. If we can free the frame by writing it content to swap space and changing the page table, we can now use the freed frame to hold the page for which the process faltered. We modify the page service routine to include page replacement. So find the location of the desired page on the disk and find the frame. If there is free frame, use it. Okay, so if there is no free frame, use page replacement algorithm to select the victim frame. Write the victim frame to the disk, change the page and frame tables accordingly. So third one, the read the desired page into the newly free frame. Change the page and frame tables. Restart the user's process. So notice that if no frames or free, two page transfers are required. This situation effectively doubles the page fault service time and increase the effective access time accordingly. So we can reduce this overhead by using modify bit when the scheme is used. Each page or frame has modify bit associated with it in the hardware. The modifying bit for a page is set by the hardware wherever any word when we select a page for replacement. So we examine its modifying a bit. If the bit is set, we know that the page has been modified since it was read in front of the disk. In this case, we must write the page to the disk. If the modify bit is not set, however, the page has not been modified since it was read into memory. In this case, we need not write the memory page to the disk. So it is already there. The technique also applies to read only pages. Such pages cannot be modified. So page replacement is basic to demand paging. It completes it completes uh, the separations between logical memory and the physical memory. So with this mechanism, the enormous virtual memory can be provided for programmers on the smaller physical memory with no demand paging. So user addresses are mapped the physical addresses. So the two sets of addresses can be different. All the pages of a process still must be in a physical memory. However, with demand paging, the size of the logical address space is no longer constrained by the physical memory. If we have a user process of 20 pages, we can execute it in the 10 frames simply by using demand paging. Okay, so we must do major problems to implement demand paging. We must develop a frame allocation algorithms and page replacement algorithm. So if we have multiple processes in memory, we must decide how many frames are allocated to each process in memory. And when page replacement is required, must select the frame that has been replaced. So designing appropriate algorithm to solve these problems is an important task because a disk IO is so expensive. So even slight improvements in demand paging methods yield large gains in system performance. So there are many different page replacement algorithms. Every operating system probably have its own replacement scheme. How do we select a particular replacement algorithm? In general, we want the generally we need that the designing appropriate to that performance. So demand paging method yield large gains in system performance. Okay, so we evaluate an algorithm by running its in particular string of memory reference and computing the reference of computing of number of page for the string of memory reference is called a reference string. We can generate reference strings artificially, which means by using random number generator, or we can trace a given system and record the address of each memory reference. So later choice produces a large number of data. To reduce the number of data, we use two facts. First, for a given page size, and the page size is generally fixed by the hardware of subsystems. So we need to consider only the page number rather than the entire address. Second, if we have a reference to a page P, then any references to page P immediately follow will never cause the page fault. So page P will be in the memory after the first reference. So the immediately following references will no fault. For example, if we trace a particular process, we might record the following address sequence. Okay. So at the 100 bytes per page, the sequence is reduced by the following reference string. So frame allocation algorithm. So it will determine how many frames to give each process, which frames to replace. Page replacement algorithm wants lowest page fault rate on both first access and re-access. So both re-access, first access and re-access both can be the page fault can be lowest. So this one, the page replacement algorithm. So evaluated the algorithm by running it a particular string. So this is a graph of page faults versus number of frames. So here we have to determine the number of page faults for a particular reference string and the page replacement algorithm. We also need to know the number of page frames available. Obviously, as the number of frames available increases, the number of pages fault decreases for reference string considered previously. For example, we had a 3 or more frames, we would have only 3 fault. The one fault, the first reference of the each page. In contrast, with only one frame available, we would have a replacement with every references, resulting in even fault. In general, we expect the curve such in that above that figure. As the number of frames increases, the number of page fault drops to some minimal level of adding physical memory. It increases the number of frames. So we next illustrate the several page replacement algorithms is doing when we have the reference string. Okay, so first we have to uh, learn about the first in first out algorithm. So first in first out algorithm. So this is the reference string that is the red in color. So 3 frames in a memory at a time per process. So you have to assume that 3 frames at a memory per process. So here the diagram can explain the reference string, how the page frames can be divided. Okay, wow. So here, so this one is very simplest page replacement algorithm is a first in and first out algorithm. So first in first out replacement algorithm associates with each page the time when the page was brought into memory. When a page must be replaced, the oldest page is chosen. Notice that it is not strictly necessary to record the time when a page is brought in. So we can create first in first out queue to hold all pages in memory. So we replace the page at the head of the queue. When a page is brought into memory, we insert it at the tail of the queue. For our example, referencing our 3 frames were initially empty. Okay, so the first 3 references, that is 7, 0 and cause page faults and are brought into the empty frames. So the next reference of 2 replaces page 7, and because page 7 was brought the first, since 0 is the next reference and 0 is already in memory, so we have no fault for this reference. The first reference to 3 results in replacement of algorithm page, that is 0. Got it? So since if it is now first in line, because of this replacement, the next references of the page for page 1 and then replaced by page 0. So this process continues as the shown in the figure. So every time the fault occurs, we show which pages are in our 3 frames. So there are 15 fault altogether. Okay, so the first in first out page replacement algorithm is easy to understand and progressing also. So it is performance is not always good. One on the other hand, the pages replaced may be in initialization model that was used as a long time ago and no longer needed. Okay, so in the first in first out replacement trigger algorithm, then we notice that we have selected the replacement page, that it is an action for everything still works correctly. As per we replace an active page with a new one, the page fault occur immediately. So figure represents the curve of um, page, and then it will explain the number of arguments. Okay, so in this, notice that the number of fault of the 4 frames is greater than the number of fault for 3 frames. So this is most unexpected result is known as Belladie's anomaly. So for some page replacement algorithms, the page fault rate may increase as the number of allocated frames increases. So we would expect the giving more memory to the processors without improve its performance. So next one is this is the illustrating of Belladie's anomaly figure. Okay, so next one is optical algorithm. So this is the algorithm that will be used for longer period of time. Okay, so on one result of discovery of Belladie's anomaly was such an optimal page replacement algorithm which has the lowest page fault rate of the algorithm and will never buffer the Belladie's anomaly. Such as an algorithm does exist and has called OPG or MIN. So it is simply this replacement the page that will not be used, the replacement of the page that are not my, so will not be used for the longest period of the time. So use of this page replacement algorithm guarantees the lowest possible page fault rate for the fixed number of frames. For example, on our simple sample reference string, the optimal page replacement algorithm would yield 9 page fault as shown in the figure. So the reference of 2 pages to place the replaces of 7 because page 7 and will not be used until the reference. Okay, so reference to page 3 replaces page 1 as page 1 we will the last of the 3 pages in memory to reference again with only 9 page fault. Optimal replacements is much better than the FIFO algorithm which result in 15 fault. In fact, no replacement algorithm can process this reference string in the 3 frames with fewer than 9 fault. Unfortunately, the optimal page replacement algorithm is difficult to implement because it requires further knowledge of the reference string. In similar situations within the SIF CPU scheduling algorithm means as a result, the optimal algorithms is used mainly for comparison studies. For instance, it may be careful to know that although a new algorithm. Okay, so third one is LRU page replacement algorithm. In the optimal algorithm, it's not feasible. Perhaps an approximations of the optimal algorithms is possible. The key distinctions between the FIFO and OPTS algorithms, backward versus forward in time, so that it can FIFO algorithm use the time when the page was brought into memory, and the OPT algorithm uses the next time when a page is to be used. If the recent page of the approximate of the near future, then we replace the page that has not been used for the longest period of the time. This approach is known as recently, which means least recently added or LRU algorithm. So LRU replacement associates with each other of the page fault. We can think of this strategy as the optimal page replacement algorithm. So we have to consider as v to the power of f to the power of r be the reverse of the reference string s, then the page fault rate for the OPT algorithm on S is the same as the page fault rate for the OPT algorithms as SR. Similarly, the page algorithms of SR. So the result applying LAU algorithms, for example, So the LRE policy is often used as page replacement algorithm and is considered to be good. The major problem is how to do implement LRE replacement and LRE page replacement algorithm. We have to order for the frames defined by the time of lost use. So to implement or feasible. So counters stack. So these are the implementations feasible in LRU. The first one is counter. In the special case, we associate with each page table entry a time of use field and add to CPU logical clock or counter. So the clock is incremented for every memory reference whenever the reference to a page fault is made. So the content of the clock registers are copied to the time of use. The time of the last reference to each page. We replace the page with the smallest time value. So this scheme requires the search of the page table to find the search every each memory access. So the times must also be mentioned and maintained when the page tables are changed. So stack next one is the another approach to implementing LRE replacement algorithm is to keep the stack of the page numbers. Whenever the page is referenced, it is removed from the stack and put on the top. In this way, the most recently used page is always the top of the stack and the last recently used page is always at the bottom. So next to the middle of the stack, it is the best of the implement with approach by using a doubly linked list with a head pointer and a tail pointer. So removing a pages or putting it on the top of the stack then requires the changing six pointers at most. So each update is a little more expensive, but there is no search for LRU. This approach is particularly appropriate for software for microcode implementations. Okay. So this is least recently used algorithms we got. Okay. So this is the LRU approximations algorithms, and we use the additional reference bit algorithms and second chance algorithm. Okay. So here the LRU means special hardware and still store reference bit with each page associated with initially is equal to 0. When page is reference bit set to 1, replace any with reference bit is equal to 0. So we do not know the order, however, the second chance algorithm. So generally FIFO plus hardware provided reference bit lock replacement. If page to be replaced has reference but 0, replace the reference bit is equal to 1, then set reference bit 0, leave page in memory. So replace next page subject to same roles. So this is second chance, that is clock page replacement algorithm. So this algorithm, when a page has been selected, however, we inspect the reference bit. If the value is 0, we proceed to replace this page. But if the reference is set to 1, we give the page a second chance to move one selected the FIFO page. When a page gets a second chance, the reference bit is clear and the arrival time reset to the current time. Thus, the page that is given for a good second chances. In addition, if the page is used often though to keep a reference bit to set, it will never be replaced. So enhance the second algorithm. How to enhance the second algorithms? To improve algorithm by using reference bit and modify bit. Take order pair, neither recently used not modified best page to replace. If not recently used but modified, not quite as good, much write out before replacement. So recently used but clean probably will be used soon. So recently used and modified probably will be used soon and need to write out before replacement. And when page replacement called for the clock scheming, but use might be in search for classes of replacement page in lowest non-empty classes. So might need to set circular sequence of queue several times. So next one is page buffering algorithm. So here the pool of the free frames always and frame available when needed, not found the fault time. So read page into free frame and select victim to evictants and to add free pool. When convert a victims, possibly keep list of modified pages. When backing store otherwise idle, write pages 3 and set to non-dirty. So applications and page replacements, all of these algorithms have OS guessing about future page access. So some applications have better knowledge, that is databases. So memory intensive applications can cause double buffering. That is OS keeps copy of the page in memory as IO buffer, and applications keeps page in memory for its own work. So operating systems can given direct access to the disk, getting out of the way of the applications, and raw disk mode. This is bypasses buffering, locking, etc. Okay, so many algorithms are seen in this video. So this is the end of the video. So you have to clearly understand the concept about page replacement algorithm and what are the types of page replacement algorithms are there and how it can be worked and the graphs to be learned. Okay, so thank you so much for everything the watching this video.